Alright, so this is my Lab 9 project, which is a little fighting robot which utilizes a ultrasonic sensor and a servo pair in order to simulate little hammers. So what that means is, you can sort of get a good view of the machine from the front there. What that means is if something's in front of it, then that means if it approaches it, that it will begin firing off those hammers. So let's say that this guy is right here, and then if I use my remote control, which simply controls essentially a separate system internally, batteries and a receiver and controllers for the motors respectively. That means I can move back and forth accordingly. So if I drive it up towards this little guy, this thing, yeah, you can see actually firing. And what this means essentially, within a certain distance, it'll begin firing, but if I back it up, it will stop firing after and reset. So according to my little code right here, you actually can see, I essentially used this initializing up in here. Basically, I created a pin for the trigger and echo function of the sensor, as well as the step function. This is basically an idea where the steps between each little degrees of the servo, I'm essentially counting the number of time between them, therefore I can regulate the speed of the whole thing, as well as the start and end positions of the servos. So by including a servo library, you're sort of able to see right side, left side, as well as the trig and echo being set to pin mode. And then we scroll down, and all this is basically set up. This function right here takes the input from the echo. Basically what this does is the trig essentially sends out a sign, sends out a little reading, and then it gets it back over this delay. And what it does is it reads it versus this pull in, and that inputs it to echo. And echo we can then use as part of the duration and then distance. So distance, basically, we use the speed of sound, which is 340 meters a second. And what we do is we turn this number down into centimeters, which allows us in order to find the accurate distance of it. So what that means is if we scroll down here, we essentially have our cutoff at 5 centimeters right now, where our servo is going to fire. Another distance, 5 to 10, it will also fire. And then at past 10, it will stop firing, and they'll just simply return to their positions. It's also important to note the servos are mirrored, so therefore their end position and start positions are flipped, whereas on one, it's the end, and the other is the start. Basically, they're both returning to the same point, the servo's rotation, but because of the mirror effect, it needs to return to the other position. So we have our processing code, which is very simply put, inputting the values from the reading from the Arduino and displaying different backgrounds in order to reflect the position distance of the object. So right now, if we hit run, we'll see that right now it starts blank, goes to blue, says destroy. That's what I want to do with the fighting robot. So right now, that blue simply says it's beyond 10 centimeters. So if we move it a little bit closer, whoopsie, hard to do with one hand. Notice it's in green, and then red is even closer than that. So with that function, we already have our processing aspect as well as our function of value. The best part about this, because the whole thing is contained within itself, that means that we actually can drive it around. So let's see that in the next part. Alright, so here's sort of the internals of the machine. So you have this ultrasonic sensor and pair of servos with the axis attached to them, which sits on the top of the 3D printed base. And they slot through this hole in order to get to the base down here. So down here is an Arduino board, which essentially is a conduit for all the different inputs. So right now, on this side, it has the digital inputs. 11 and 12 are from the servos, and then 9 and 10 are from the trigger and echo of the ultrasonic sensor. And they all plug in. So then the Arduino here essentially has 2 bits for voltage movement. So we have the 5 volts ground, which goes to the ultrasonic sensor itself, and it also has ground and V in, which comes in this battery here. And so this battery plugs into this connector, which essentially transmit power both one to the board via the yellow and the green, as well as to these controllers, which control these motors, which then connects to this receiver. And this receiver simply pairs up to my controller here and allows the drive base to function totally independent of the Arduino. So essentially this is like a remote control car where it has an autonomous element to it. Now on to the driving test.